just for the fun of it, let's do some logarithmic differentiation problems. There's two categories of problems that logarithmic differentiation really applies well. One is where x is in the base and in the exponent. Really, you might think of this as sine of x to the x, and you could have x to the x or anything down here with an x and anything up there. It's not a polynomial, it's not an exponential. What do I do when x is in both places? Well, the answer is you need logarithmic differentiation. You take natural log of the left, you take natural log of the right, and of course the real benefit of natural log is that the exponent, the x there, can come in front. So it's just a product rule problem. Okay, so now I use implicit differentiation. Derivative natural log of some big mess is 1 over that mess times the derivative. I'll write that as y prime. Derivative of a product is derivative of the first 1 times the second plus x times the derivative of this. I'm going to have to use a little chain rule action. Natural log of mess is 1 over sine of x times the derivative of the inside. I could write cosine x there, or I could write it on top, right? So that's what I've got. How do I solve for y? Well, you write, sorry, y prime. I want to know what the derivative is, y prime. You have to multiply both sides times y, right? So I'm going to multiply this side by y, put y over there. Natural log of sine x plus x cosine over sine. I'll just go ahead and simplify that. That's cotangent. Well, what is y? I could write y here literally, but I know what y is. So I'll just go ahead and write sine of x to the x power. Okay? That's the first category where x is in the base and x also appears in the exponent. The other category where this is really common is where you have just a whole bunch of terms here. Okay? Now, technically, you could use a whole mess of product rules and quotient rules to get this, but notice what happens if I took the natural log of it. Natural log splits products apart, so I'd have natural log of 3x plus 2 to the 6th. Oh, wait, the 6 can come in front. Natural log splits a product apart. This is natural log of 7x plus natural log of x plus 1 minus, because it's in the denominator, natural log of 2x cubed minus 1 to the 1/2 power, and you can pull that out in front. So the log properties change these, so you've just got a bunch of terms added and subtracted. Now I use implicit differentiation just like the last one. Shockingly, the left-hand side becomes 1 over y prime. 6 times this is 6. Natural log, its derivative is 1 over 3x plus 2, but I've got to use the chain rule, so times the derivative of the inside, which is 3, plus the derivative of 7x, that's 1 over 7x times the derivative of the inside, which is 7, plus the derivative of x plus 1, that's 1 over x plus 1 times the derivative of the inside, which is just 1, minus 1/2. Derivative of the inside is 1 over 2x to the 3rd minus 1. Derivative of the inside is 6x squared. Okay, so how do you get y prime by itself? Answer, first off, you multiply both sides by y. Multiply by y over there, multiply by y over there. What's y? It's that. So it's sometimes a little bit of a hassle to write this. You wish you had a copy and paste on the back side of your pencil, but it's at least not too complicated to copy exactly what's listed above. Okay, so there's y times what's just right here. So 18 over 3x plus 2 plus 1 over x plus 1 over x plus 1 minus, maybe we ought to simplify that a little, 3x squared over 2x to the 3rd minus 1. Hope that's helpful.